Welcome back to the classroom. My name is Mr. Wong. Today we'll be covering a question from Module 4 Inquiry Question 1, Electrostatics, with the 2020 QATs Physics paper, Question 28. We have a small positive charge with a charge value of 5.5, 10 to the minus 2, moving from position X to position Y, so from here to here. Okay. It says calculate the work to move the charge from position X to position Y. Now we know that the formula for work done is force times displacement. We know that in terms of the force from the equation that force is equal to charge times electric field strength. Okay, so that's what we have here. Okay, so let's get into the calculations. Firstly, we need to work out the electric field strength. Okay, so our electric field strength is the change in potential. If you can see here, it goes from 200 to 100, so that's what we're seeing here. So change in voltage or change in potential is 100 divided by a distance of separation of 5 times 10 to the power 2, negative 2 that is. Plug that into our calculator. We get a electric field strength of 2000. From there we want to find the overall force. The charge we already said was 5.5 times 10 to the minus 2 times 2000. Okay, so what do we get? We get a force of 110 newtons. Okay, because it is a positive charge. Okay, so positive charge, we get a positive value here. Okay, it says we're taking it into the direction that we have there. Okay, and then in terms of total work done, work is F times distance traveled. So the force we exert is 110 times the distance, which is 3 centimeters. Convert that into meters. And let's look at what we get from there. So we used up 3.3 joules of energy to move the charge from position X to position Y here. Notice we don't really factor in the horizontal component because that's not the actual work that's being done. The work that the displacement was shown is this bit. So the force of pushing it down this way is also the work or displacement point that we want to look at here. That's complete. Question B, it says when the charged particle is released from position Y, it accelerates. Describe the direction of the particle's acceleration. Okay, so in terms of the direction, because we have positive particle, so because it's a positive particle, it will accelerate to the negative plate. Okay, and we can even write this is due to electrostatic attraction. So that's kind of the reasoning for this to occur. If the particle experiences an acceleration of that particular value there, when it's released from position Y, determine its mass. So we know that the force that we said was being exerted on the particle was 110 newtons. We say that the acceleration is 2.75 times 10 to the power 7. So the mass, which is force divided by acceleration, can be written like so. So the mass that we get, again, plugging into my calculator, is 0.000504 kg. So that would be the mass of my charged particle. You could always put it in scientific notation, so it would be 1, 2, 3, 4, 5, 6, 4 times 10 to the power of -6 kg. And that's how you do this question here. Hopefully you found this video useful in exploring this question. Give it a like for support, and take care.